Hello, welcome. The purpose of today's video is to start talking about the idea of acceleration, standard 1.9, and relating it with velocity and displacement, particularly in terms of graphs. All right, so let's think about what this idea means. So far, we've only talked about constant acceleration. What is constant acceleration? Well, constant acceleration, I picture anything moving. Let's say it's a person running, and their speed, their velocity isn't changing. So let's say the person runs 1 meter in 1 second. They've gone 1 meter in 1 second. Their velocity is 1 meter per second. And then in the next second, how far should they go? Well, if it's constant velocity, they're going to go 1 meter again. Their velocity is still 1 meter per second. And then they just keep going 1 meter every second. Great. So that's one way that people could move. But have you ever seen someone move in a way in which these velocities might change? Sure you have. You might have seen a sprinter at the Olympics speeding up. You might have seen a car start from 0 meters per second and then start driving at some acceleration to however many meters per second. You might have seen a skydiver falling from the sky and accelerating down towards the ground before they open their parachute. So lots of motion in real life actually involves accelerated motion. Try and come up with an example on your own here. What's another example of motion that's not constant, but the motion's changing? All right, hopefully you came up with a great example. So, accelerated motion, what would that look like on a map here? Well, maybe I still start out going 1 meter in 1 second, but then maybe in the next second, I'm actually able to cover 2 meters. And so now I've gone from 1 to 3, that's 2 meters in 1 second. And then maybe in the next second, I'm able to cover 3 meters. So from 3 to 6. So then I'm going 3 meters per second. You'll notice my velocities, the amount of displacement I do over time, are changing. I'm moving faster as I go. You could, of course, also start at 3 meters per second and move slower to get down to 1 meter per second. Accelerated just means motion changing, or velocity specifically changing. So it could be speeding up, it could be slowing down. Great, what does this look like on a graph? Well, so far, we've seen graphs with constant velocity. We've seen time and displacement where it makes a linear line, and we have come up with a formula for that. Final displacement equals velocity times time plus initial displacement, and we've recognized that the velocity is going to be the slope of this graph. So we get some slope, and whatever number the slope is equal to, well, in a velocity time graph, we just graph that slope. So whatever number the slope is equal to, we plot that here, and the velocity does not change over time. At every point in time, the velocity is exactly the same. Great, so what would this look like for changing velocity? Well, I still have my time and displacement graph. Remember, S is displacement, but the graph's gonna look something like this. And so that means at each point of this graph, there's a different slope. So I could get the slope right here at this point, and the slope is going to be equal to whatever the slope of this line is. And I could get the slope at this point. And this slope is going to be equal to whatever the slope of this line is. The slope is changing. Now, what was slope in a displacement time graph? Well, slope in a displacement time graph gives me displacement or distance over time measured in meters over seconds. That's velocity. So I see my velocity is changing. It's a different number at each point along my graph here. Well, what does that mean for my velocity time graph? Well, it's going to look something like this. Let's say I start at rest, I'm not moving at all, And now my velocity is going to change. With each time point, I'm going to have a different velocity. So it's going to look something like this. So the slopes here in my displacement time, we plot as different velocities in the velocity time graph. All right, so now what we look at is we have velocity over time, and we have a linear line here. So like with any linear line, we can find the slope of this line, and the slope is going to be how the velocity changes over time, and that's equal to acceleration. The other thing to notice there is the units. For the slope here for acceleration, well, velocity is measured in meters per second, time is measured in seconds, so acceleration is measured in meters per second divided by seconds, which is meters per second squared, how velocity changes over time. Thanks so much for watching. Have a good day.